So this video is going to focus on epoxidation of alkenes. Let's just jump right in. What is an epoxide? An epoxide is a cyclic ether. Shown here, it's a three-member ring with oxygen, carbon, and carbon together, and oxygen is singly bound to each carbon. It's a type of ether. And there are two methods to do epoxidation. One method is to use MCPBA, which is metachloroperbenzoic acid. That's shown here. Sounds very intimidating, but it's just a source of oxygen for the reaction. And then if you'll notice, I'm taking an alkene. If I treat that alkene with MCPBA, then I get what's called an epoxide here in my product. Method B uses hydrogen peroxide and then sodium hydroxide and ethanol, which is just my solvent. All right, and again, I'm taking an alkene and I'm converting it into an epoxide. So if you see these reagents, you know that you are taking a double bond and transforming it into an epoxide. So when you make your flashcards, make sure that these reactions are shown and that the reagents are properly shown, so that you will know, you'll be able to distinguish these reactions from other reactions. So let's look at what happens. So now here's my MCPBA. Notice the hydrogen bond here holding this thing together. The red oxygen here is what's going to end up on my bonded here to each one of the carbons in the double bond. So let's look at the arrows. Right, the electrons come here from the OH bond. The double bond attacks this oxygen and breaks the OO bond. And so let's look at what the transition state would look like. All right, all of these dashed and dotted lines mean something. So some of these bonds are breaking. The pi bond here is breaking. These two sigma bonds between oxygen and carbon will be forming. This oxygen-oxygen bond is breaking. This carbon-oxygen pi bond is forming. This carbon-oxygen pi bond is breaking, and then the OH pi bond is forming here, and the OH bond is breaking here. So let's look at what we get as a result of that. All right, I get metachlorobenzoic acid, which is here, and I also get my epoxide. Notice the red oxygen here is the oxygen that got transferred here to the double bond to make the epoxide. And again, the epoxide is just a cyclic ether. It's a three-member ring with oxygen singly bonded to two carbons. All right, now if we look at method B and use hydrogen peroxide, the first thing that has to happen in that mechanism is the hydrogen peroxide has to be activated. So then sodium hydroxide comes in, deprotonates here, and then I get a peroxyanion, which is here. If you recall, this is the same thing that happened when we did hydroboration oxidation, where we get the peroxyanion. All right, that anion now comes in and attacks my double bond. So now the oxygen attacks here, the double bond attacks oxygen and breaks the OO single bond. Look at the transition state where I have the pi bond being partially broken, these two bonds being partially formed, and then a partially broken bond here between oxygen and oxygen. Now let's look at the product. Right, the product is here, where now this oxygen here is now here in this three-member ring, and then OH minus, just a side product, is going to get picked up by sodium plus, and so it won't stay as OH minus. All right, so now we see there are two methods for epoxidation. One method is to use MCPBA. The second method is to use hydrogen peroxide and sodium hydroxide. Either one of these two methods will give you the same thing, an epoxide in the product. The only difference is one of them is used for more electron poor double bonds, which is hydrogen peroxide, and then the other one is used for more electron rich double bonds, which is MCPBA. All right, so we'll stop here. We're going to pick this up. I'm going to continue to post these reactions on a daily basis until we're done with this chapter. So take notes, ask questions. I will have a quiz posted for this on Monday, so you'll have to take that quiz, and we'll just keep going until we get these reactions hammered out. As always, if you have any questions, you can tweet, you can email, or you can drop by my office. Peace.